it describes the probability that a result or a relationship that we find is due to chance. So it is the probability that we would find that relationship at a flip of the coin. Meaning that the lower the probability that it's due to chance, the more certain we can be that the results can be generalized to the population. So the lower that probability, the more certain we can be that the results are not due to chance. So this is all about being able to take the results from partial observations and being able to say this is true in the population, regardless. I mean, that's all we're trying to do here is take this small information from this small group sample and be able to say that the relationships that I find in that small sample, the relationships between variables, the comparisons that I make, the description that I find, is also true for the greater population. That's all we're trying to do here. Being able to do that and being able to calculate with a degree of certainty that this relationship would be true in the population is what inferential statistics are about. Can I infer? Can I infer to the population? Because if we can do that, if we can infer our results to the population, then we can make predictions. We can actually predict behavior, which is a goal for social scientists. Oops, went a little too far. So the statistical significance is a probability that the relationship we find in the sample is due to chance, due to randomness, if that word fits better. So due to chance, or that it's basically random. So you're studying a sample of 100 people, but you really want to be able to infer your results or generalize your results to every student at an institution, all 23,000 of them that are at your institution. You're a big college. The statistical significance of our statistics is a probability that relationship that you find in your sample of 100 people is the result of randomness, the result of chance. And the smaller that number, the smaller that probability, the more certain we can be that it's not due to chance. The smaller the probability, the more certain we can be of finding that relationship in the population as well. That is inference. Okay, a little bit more about this concept of significance, statistical significance. Let's look at this hypothesis. As the hours spent studying goes up, this is my notation, then GPA goes up. So this is my hypothesis. The more we study, the higher our GPA. We can correlate this because this is an interval ratio level data, measured data, number of hours, and we like to treat GPA as interval ratio. So I could correlate these two variables and find a correlation. We learned about that in descriptive statistics. So if I correlate these two variables with the Pearson R, and we find that indeed the Pearson R is statistically significant with a p less than or equal to 0.03, then we can say a number of things. These are the different interpretations of p less than or equal to 0.03. P stands for probability. And the way that we can interpret this statement, basically, is this. It's the probability that the results are due to chance is 3%. Probability is 3%. So in order to do that, figuring out this percent, just move the decimal places over 2 points, 3%. That's how you find the percentage of the probability. Just move the decimal place 2 points. So the way to interpret this is the probability that the results are due to chance is 3%. That's pretty low. That means we can be 97% certain that the relationship that we found, that number of hours of studying goes up, our GPA will go up. We can be certain that that relationship is true in the population. 97% certain. That's pretty high. I wish we had that kind of certainty. Another way to interpret p less than or equal to 0.03 is your risk for being wrong is only 3%. Remember, we hypothesized that as hours go up, GPA goes up. If we find p less than or equal to 0.03, our risk for being wrong on that hypothesis is 3%. These are not different. These are how you can interpret this statement. Finally, if this relationship did not exist in the population, the probability of finding this relationship in a sample would be 3%. So that's really low. If it doesn't exist in the population, we don't have a very high level of probability for finding it in our sample, in any sample. So that is basically another way of saying that if the relationship does exist in the population, we can be 97% certain that we'll find it in our sample. So they're saying the same thing, all three of these, but they're kind of three slightly different interpretations of p less than or equal to 0.03. P standing for probability. This statement is about statistical significance. That's how you interpret that. Okay, so a little bit more about convention and statistical significance. The rule of thumb for statistical significance that's accepted is p less than or equal to 0.05. There are very few rules in statistics, but there are conventions, and this is probably one of the most important conventions. Researchers have accepted that this level of probability is good enough. That the 5% chance of being wrong is reasonable to be able to say that your findings are statistically significant. Okay, so there's a lot of different words here and there's some nomenclature. So P, we have been saying this P stands for probability. It has some different names too, and you'll see this in the literature. It can also be called the p-value. And that's pretty much the phrase I'll be using. It can also be called the alpha level. So you'll see it written like that, or you'll even see it with the Greek letter, alpha, the alpha level, along with level, alpha level. Okay, so the accepted convention for statistical significance is p less than or equal to 0.05. P-values are reported like this, with an asterisk. One asterisk means p less than or equal to 0.05. Two asterisks mean p less than or equal to 0.01, which is less than this. So all these are statistically significant because these numbers get smaller, they're less. Three asterisks, p less than or equal to 0.001. And that's it. This is all that you would report. You could just report the asterisks. And I'll show you some examples of how researchers do this. This ends this part of the module's presentation. Please move on to review the next part